Okay, if you're just tuning in, this is Mr. Brown. Sorry that you do not get to see my lovely face, but oh well, you'll get over it. Today's podcast is about mid-segments, special segments, and inequalities. What I'm doing really is just I'm just working a few problems from this quiz here that my students seem to do a very, very horrible job on. So here we go. If you'll notice that 1 through 6 is just a mixed mash of, hypotenuse with right triangles and inequalities and all sorts of stuff. So here we go. Number 1, if you'll notice that this has to be a right triangle. So for number 1, it will follow the Pythagorean theorem, which the formula for that is c squared equals a squared plus b squared. I intentionally put the a right here because you need to know that this a goes in place of the c. So you're going to rework the Pythagorean theorem as to a squared is equal to 9 squared plus 4 squared. And whenever you rework all of that out, you wind up with a squared is equal to the square root of 81 plus 16, and you simplify from there. Okay. Now number 2. Here we go. You cannot do the Pythagorean theorem on this one, and the main reason why, is because it's not a right triangle. You always have to look and make sure that it's a right triangle before you can go on. So, since it's not a right triangle, we don't know exactly what B is. There is no way in the world that you can say B equals something. What you can say is that B has to be bigger than something and less than something else. So what you do is you take these two sides right here and you compare them. You do a 16 minus a 9 and a 16 plus a 9. B has to be smack dab in the middle of those. So it has to be in between, what would that be, 7 and a 25. That is how it goes. Okay? For number 3, it's the exact same way. You don't know exactly what C is. C is going to be in between these two numbers added and subtracted. I'll give you a second. And that's right, 12 minus 12 and 12 plus 12. So that's going to give you what? A 0 less than C less than 24. So the question is, can C equal to 1? Well, sure, because it's bigger than 0. Can C equal 23? Sure. Can C equal 24? No, because C is not less than 24 if C is 24. Next, this is called the mid-segment right here, mid-segment. With that being said, the mid-segment has two properties. Property number 1, it's always half the base. So if this is the mid-segment, then this is the base right here. So since this is the base and this is the mid-segment, the base is always double the mid-segment. So if that's 16, that means the base is going to be 32. We'll use the other property in a little bit, but the other property is it is also parallel to the base. Okay, now that's its properties. The definition of a mid-segment is that it connects the two midpoints. It connects the two midpoints of a triangle. So, since this 32 right here is the mid-segment, how much does the base have to be? Well, if the mid-segment is 32, you double it and you get, that's right, 64. So this line right here has to be 64. Well, it's already a 2e minus 18, so you set them equal to each other and you go from there. That would mean that number 5e is equal to a 41, not 411. 411. Ain't nothing. Okay, here we go. The property is this. If this is a perpendicular bisector, which it is, because it's perpendicular, and it bisected that line, that means this point right here has to be equidistant from here and here. Equidistant. That's the word I just said, so that's the word I'm going to use. Equidistant. Distance or distant. That means it's the same. Duh. So you're going to work this out. 3f plus 2 has to equal to 7f minus 10. Solve it, 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 solve it. Pause on your video. That's right, f equals 3. Okay, good. So let's move on to something else. So let's go to number 7. Because we need to know how to do number 7. For number 7, In triangle ABC, point D is a midpoint. So duh, you have to draw a triangle ABC. So here's A, here's B, here's C. Doesn't matter. I could have drawn a triangle like this and put A, B, C. That doesn't really look like a triangle, but you know, who's counting? All right, so point D is a midpoint of AB. So here's point D because it has to be right in between A and B. Point E is a midpoint of A and C. So here's point E because it has to be right in between A and C, and I'll label that as an E. If AE is 24 inches, so AE is 24 right here, and DE is 16 inches. DE is 16 right there. How much is EC? Question mark. Well, I'll give you a second to think about it. Is it going to be 16, or is it going to be 24, or is it going to be 32, or is it going to be 48? Nope, 48 goes way down here because it got bisected. That's right. So this is just going to be 24. That's the answer to number 7. Let's go to number 8. Number 8. Here we go, number 8. Can the following measurements of a triangle be true? Well, I have no idea what all this little bit of writing is, so here we go. Just pick one of the numbers. You have to decide, if I took a little stick of 7, and a little stick of 9, and a little stick of 12, can I make those into a triangle? Well, you can take the little stick right there as a 12, you know, you can whip that as a 9, and that, your 7 would only come to right there. So then you swing it over here, you know, there's your 7, there's your 12, then you bring it over there, there's a 9. So that looks like it's going to be. The only way you decide is you pick one of the sides. You can pick the 7, the 9, the 12. Some students pick the 9 because it's in the middle. Some people pick the 12 because it's the biggest. That's what I do. So I'm going to pick the 12 because it's the biggest. Why did I pick the 12? Because it's the biggest. So this 12 goes back to what we were saying. The 12 has to be in between the other two, 9 minus 7 and 9 plus 7. Well, 9 minus 7 is 2. 9 plus 7 is 16. So is 12 in between 2 and 16? Yes. So can these be a triangle? Yes. Let's check this one. I would choose a 35. Why? Because it's the biggest. So I do 30 minus 5, which is 25. And then less than 35, less than 30 plus 5, which winds up being 35. This doesn't work, so the answer is no. It cannot be a triangle. It's going to be the same exact thing. This one winds up being a no, and this one winds up being a yes for sake of time, because we're running into a pretty long podcast. Alright, so let's move it on. We are going to number 9. It's the same way. I'm just going to take a little bit shorter route. So number 9. Give an equality representing the values of the third side of the triangle with the following measurements. So basically it says, hey, these are your first two. What's your third one? Your third one's going to be x, so it has to be in between 20 minus 14 and 20 plus 14. So that's how you do that. I don't know what's going on. What's going on? Right there, right there. Okay, so that's going to be 6 less than x, less than 34, and da 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 da. So that's good. A 4 and an 8 and a 0 and a 60. So x has to be in between all of that. Okay, so here we go to 10. The mainstay, number 10. Number 10. You got to figure out which one these are. I hope you stuck with me all up until this podcast, because here's the crux of it. With this being said, here we go. Number 10. Give the term that identifies the special segment. Well, this right here. You got to know your special segments, so refer to the website terms. There's a link on there that gives you the terms of all of these. First of all, it's perpendicular. So since it's perpendicular, it could possibly be an altitude, or it could be a perpendicular bisector. So an altitude has to go through the opposite vertex. Here's the opposite vertex. Did this line go through that point? No. So it's not an altitude. Perpendicular bisector, don't get caught. Did it go through, are these tick marks there, meaning it went through the middle? Yes, so perpendicular bisector. Letter B. This point right here is midpoint. It goes through the opposite vertex. Connection of the midpoint to the opposite vertex makes it a median. Median. Go watch the podcast. Angle bisector. There is an entire podcast devoted to special segments of triangles. Altitude, because it's perpendicular and there were no tick marks. Again, perpendicular and going through the opposite vertex. Altitude. Let's see. A lot of people try to call this an altitude, but there's no perpendicular line. If there's no perpendicular line, it's not an altitude. Duh. Okay. And since it's no perpendicular line, it can't be a perpendicular bisector, which makes this thing a median. Same way with this. Is this a median? Well, it goes through the midpoint, yeah, but it didn't go through the opposite vertex. It's got to go through the opposite vertex. Perpendicular bisector. I hope this helps you remember all these special segments and how to do inequalities. Thank you very much.